In this video, we will be talking about how to calculate a critical value, specifically z sub alpha over 2. So the first thing we want to discuss is what is a critical value. So there are different types of critical values based on different distributions, but in this video we're concentrating on z sub alpha over 2. And what it is, it's a z-score that's based upon alpha, your level of significance. So 90% level of significance versus 95 versus 99. There are different z values associated with those. This critical value has different names depending upon where you look. Some places call it a z value, some places call it a multiplier number, some places call it a confidence coefficient. When doing hypothesis testing, this is the value or values that separate the critical regions, the regions that identify where weird, strange, unusual things happen. When do we need this z sub alpha over 2? Well, we use it whenever we're calculating sample sizes. For a population mean, it's our numerator here, or a population proportion, it's our numerator here. Also, if you're calculating sample sizes for proportions, you have two different formulas. So this is the formula if you do not have any prior estimates, and this is your formula if you do have prior estimates. You also use z sub alpha over 2. It's your critical value when you're calculating your confidence interval. So you multiply that critical value times your standard error, and both of these items together give you your margin of error. Same thing when you're working with mean problem, calculating your margin of error just by itself. It's also used when you're doing hypothesis testing for two-tailed tests for proportion problems only. So how do we calculate it? Depending on the technology that you use, there are different ways to do it. So one way is to use a software called StatCrunch, and where we're going is under Stat, Calculators, and Normal. So here we want to find the critical value that's associated with the 98% confidence interval. And what you need to know is that with this confidence interval, it's always the value in the center. So we have our bell-shaped distribution, and it's saying that 98% of our data is in the center. And so in StatCrunch, there's an easy technique to figure that out. But when we're talking about critical values, we only want the positive z-score that's associated with this particular spot. So when we're looking at StatCrunch, we're going to go to Stat and Calculators, then Normal. And under StatCrunch, you have the option of selecting the Between tab. So our mean and our standard deviation is 1 because z means we're working with the standard normal distribution. So that automatically means our mean is 0 and our standard deviation is 1. So in this right-hand side, we can enter our area, also known as our probability, 0.98, because that is the area in the center. And it gives us our two z-scores. It gives us the negative value and the positive value. And so what you have to know is that when we're talking about the critical value, we only want the positive z-score. So 2.33, rounded to 2 decimal places. If you're a calculator person, where we're going to go is under second and vars, and we want the inverse norm function because z is referring to our normal distribution. So we press second and vars, and then the third option that we want is inverse norm. So here is what your calculator will look like for the new operating system. So what we need is our area, and under the new operating system you can actually select where your area is. So just like with StatCrunch, if you know that you have 98% confidence interval, that means 98% of our data is in the center. So with the new operating system, what you're going to do is put in the area that's in the center, 0.98. Then we're going to enter our mean 0, enter our standard deviation 1, and our tail we're going to select as the center and paste. So it gives us, once again, just like Stat Crunch, the negative value and the positive value. So you have to know that your critical value is only the positive z-score. So we have this value. If you don't have the new operating system, then when we go to distributions and inverse norm, this is what your calculator is going to look like. So this inverse norm function only takes the area that's on the left, then it takes your mean and your standard deviation. So far all we have is the area in the middle is 98%. So we need to do a little bit of extra work. So if 98% of our data is in the center, then we have to figure out what's on the outsides. So 100% represents everything that's under our curve. So what's on the outside is 2%. Then we need to figure out what's just on each individual end. So we take 2% and we divide this by 2. We need to split it in half because our distribution is symmetric. So 1% is on both sides. So we have 1% on this side and 1% on the right side. Your critical value is always the positive z-score that's associated. So we want the z-score that represents this place. So we need the area on the left of this point. So our area on the left is everything on this side together. So the 98% that's in the center and the 1% that's on the outside. So 98 plus 1 gives us 0.99. And since we have a z, that means standard normal distribution, our mean is 0 and our standard deviation is 1. There's our positive z sub alpha over 2 using the calculator. You can also do this in Excel as well. So in Excel, the function we're going to be using is norm.inv. So in Excel, we start off with the equal sign. There's our norm.inv. We need to enter in our probability first. So just like the calculator, everything to the left, 0.99. Our mean is 0. Our standard deviation is 1. There's our 2.33. You also have various websites that are available that you can do this as well. So here's the first website, your normal probability calculator, mean 0, standard deviation is 1. We can select less than or equal to, and the area is 0.99, just like we did here. So that will give you your z-score. Here's a different website where you can select, just like StatCrunch, that you want values in the center and your probability in the center, 0.98, and there it gives you 2.33. So depending on your technology, different ways you enter the data, which you need to always remember, critical value is always the positive z-score, your level of confidence is always in the center, and then your technology can do everything else for you. You just need to know whether you need to enter in the area on the left or do you have the option of entering the data in the middle.